You think quantum reality is confusing because it is too small to see. You imagine tiny objects behaving strangely, little particles, broken pictures. I am telling you calmly that idea is wrong. The problem is not size. The problem is sight. You keep demanding an image. You ask what an electron looks like. You draw paths. You sketch waves. You search for shapes. And the moment you do this, you have already stepped outside physics. You assume that if something is real, it must be visually representable. You assume reality owes your eyes a picture. This assumption feels harmless. It is not. Your intuition was trained on tables and stones, on objects that remain what they are when you look at them. You carried that habit into the atomic world without questioning it. I did question it. Quantum phenomena do not submit to vision. They resist it. Not because they are mysterious, but because vision is the wrong demand. Every picture you try to form smuggles in ideas you were never invited to use. Position, continuity, independent existence. Those ideas break the theory you are trying to understand, so I will not give you an image, I will take one away. If you cannot abandon the need to see, you will never understand what is happening. This is where we begin. You have been trained quietly to believe that understanding requires a picture. You imagine a spinning ball. You imagine an arrow showing the direction of a force. You imagine a ripple spreading across water. Physics reinforced this habit. Equations were made to be visualized. Diagrams promised clarity. Even graphs whispered the comfort of control. And it worked. Planets obey predictable orbits. Thrown objects follow curves your mind can trace. Light moves in ways your eye can sketch. So you internalized a dangerous rule. If I can picture it, I understand it. And worse, if I cannot picture it, the theory must be incomplete. This rule feels reasonable. It feels almost scientific. It is a trap, because it was never tested. It was inherited from classical physics. From everyday life, your eyes evolved to track medium-sized objects moving slowly in stable environments. They were never designed to follow electrons or photons. They were never meant to understand events where measurement itself defines what is real. Yet you bring this habit into the quantum world. You carry the assumption that reality must respect your visual intuition. And you do not notice how quietly it sabotages your understanding. Early atomic models encouraged the illusion. Electrons as tiny planets, orbits drawn as lines, paths traced with comforting certainty. These were not discoveries. They were scaffolding for the imagination, a way to feel that the quantum world could still be familiar. Small things doing slightly odd versions of what you already know. But here is the danger. Every time you insist on a picture, you introduce assumptions you are not entitled to. Position, continuity, independent existence. Assumptions that break the very theory you are trying to understand. The failure is not in quantum mechanics. It is in your expectation that understanding must be visual. If you cannot let go of pictures, you will fail before you even begin. This is the first crutch you must abandon, not because quantum reality is mysterious, but because your definition of clarity is too small. You must learn to see without seeing. You think that observation is passive. You imagine looking at a chair. You imagine that nothing changes because you noticed it. Your eyes gather information quietly without interference. This is how you believe the world works. It does not. At the quantum scale, to look is never passive. Every act of measurement is an interaction, a collision, an exchange of energy, a defining event. You do not merely observe an electron, you force it to act. The moment you ask, where is it? You are no longer asking about a pre-existing position. You are defining the position. This is subtle, and it is dangerous for your intuition. Change the experiment, and the electron behaves differently. It is not that the particle is hiding. It is that your question produces a reality that would not exist without the conditions you impose. This is why I insist on care in your language. You cannot claim that observation uncovers a hidden truth. You can only describe what the experiment produces. Every diagram you draw, every path you imagine, must now be questioned, because the act of seeing itself alters what you think you are seeing, and you must notice the familiar picture collapses entirely. There is no hidden camera, no silent observer. Every observation is a performance, a dialogue between the experiment and the world. This is why I say stop imagining, stop reaching for hidden trajectories, silent motions, invisible clocks. They do not exist outside the interaction you create. The error is not in physics. The error is in your assumption that observation is neutral. If you persist in the old habit, assuming seeing is passive, you will misinterpret every experiment. You will demand that nature show itself in ways it never promised. This is where intuition begins to fail, and where real understanding begins to appear. You ask, where is the particle? What is it doing? I tell you the question is meaningless until you define the experiment. You expect that particles have positions, velocities, and paths, quietly existing even when you are not looking. You imagine a hidden truth waiting to be uncovered. This is wrong. Quantum objects do not possess definite properties, independent of context. There is no secret ledger of positions and momenta. There is only the phenomenon created when you interact with the system. You must understand this carefully. I am not being evasive. I am describing the structure of reality at this scale. Ask one question, and you will get one answer. Ask a different question, and the answer changes. The particle does not remember what it was doing. It does not have hidden traits that survive beyond your experimental choice. You see, your intuition insists on continuity. It demands that properties exist quietly, waiting to be observed. I refuse that illusion. Reality at this scale is not a replay of your expectations. It does not behave like a classical object. It does not obey your instinct that something must be there even when I am not looking. Every measurement defines the reality it produces. There is no deeper, pre-existing image behind it. There is only the phenomenon, only the relationship between system, measurement, and result. You feel discomfort. You want a picture of what is really there. You want an electron to be somewhere when you are not looking. That desire is the trap I warned you about. Let go of it. The world at this scale is not a miniature version of the familiar. It is not a secret classical world hidden behind uncertainty. It is a new framework where properties emerge only through interaction, not existence. If you cling to the old habit, you will always misunderstand. You will seek a trajectory that does not exist. You will demand a story that the system cannot tell. Accept this, and the path opens. You do not measure what is already there. You create what can be said. You think there must be a single, complete picture of reality. You imagine that, if only you could measure carefully enough, you would see all properties at once. Position, momentum, wave, particle, a coherent story, a hidden blueprint waiting to be discovered. It does not exist. Nature at this scale refuses your demand. Some experiments show the particle like behavior, others show the wave like behavior. You cannot combine both into one consistent picture. This is not an imperfection of our knowledge. It is a law of the phenomena. I call this complementarity. It is not optional. It is unavoidable. You may feel frustration. You may feel a loss of certainty. But it is precisely here that understanding begins to deepen. You cannot force reality into a single mode. Your classical intuitions demand it. Your imagination seeks it. But the world itself does not comply. Observe one aspect and another slips away. No clever diagram, no hidden trajectory, no hypothetical underlying reality can reconcile them. Each experimental setup brings forth a reality consistent only with itself. I do not apologize for this. I do not offer a replacement story. There is none to offer. Your insistence on one unified picture is your own limitation, not the world's. You must accept the impossibility. Only then can you see what quantum phenomena allow. Reality is richer than any single perspective. And when you abandon the idea of a single visual truth, you begin to glimpse the structure beneath. Complementarity is not a choice. It is a boundary. The boundary your intuition cannot cross unless you surrender the demand for completeness. You expect that I should describe reality directly, without compromise, without metaphor, without the constraints of human perception. I cannot. I must speak in the language you understand. I must use classical terms: position, momentum, time, space, not because reality itself conforms to them, but because this is the only language in which I can communicate experimental results clearly. You may feel a tension here. You may feel I am lying. I am not. I am choosing the words that preserve meaning. The true behavior of quantum systems does not follow classical logic. It does not follow visual intuition. It does not follow continuous trajectories. Yet I must describe the outcome of experiments in terms you can grasp. Otherwise, we would have no shared knowledge, no agreement, no science. This is why I insist, do not confuse the language with the reality itself. The words are scaffolding. The phenomena are what remains when you remove expectation. Every classical term smuggles a small assumption. Position implies continuity. Momentum implies pre-existence. We must use them carefully. We must accept that they are imperfect guides, that the true nature of the phenomena cannot be fully expressed in words you know. This is not a failure of physics. It is the price of human understanding. You may resist this. You may seek a better vocabulary, a more perfect diagram. It will fail. To grasp quantum reality, you must accept that your words are tools, not mirrors of existence. You are not describing reality. You are describing what your experiment allows you to describe. And only by respecting that limit can you move forward without confusion. You want to know what is really there. You want a picture behind the experiment, a secret truth hiding behind the results, a trajectory, a path, a particle quietly moving along, waiting to be discovered. Stop. There is nothing behind the experiment in that sense. The demand itself is the error. Reality at this scale does not contain hidden pictures. It does not obey your insistence on visualization. Every property emerges only when the conditions of observation are defined. There is no independent existence of attributes beyond what can be measured, no silent ledger, no pre-recorded history. You may feel unease. You may feel a desire to insist on some classical comfort. Do not give in. This is the boundary of human intuition. You are trained to think that the world must be something you can imagine. I tell you it is not. Trying to invent a hidden reality only leads to confusion. You create contradictions. You invent paradoxes. You insist on paths and positions that cannot coexist. The lesson is simple, though difficult to accept. Do not ask what is really there. Ask only what can be said, what can be observed under the conditions you choose, and nothing more. Abandon the quest for hidden pictures. Abandon the illusion that understanding requires a visual representation. The world is not yours to sketch. It is yours to describe carefully, and only where your actions allow. This is not resignation. It is recognition. The recognition that reality has limits that thought alone cannot cross. When you accept this, the phenomena themselves begin to reveal a different kind of order, one that does not rely on sight, but on relation, on interaction, on principle. You are no longer seeking an image. You are seeing the structure of possibility itself. Now, imagine a world where seeing is no longer required. You have abandoned pictures, abandoned trajectories, abandoned the demand that reality obey your eyes. You no longer ask for a hidden particle, a path, or a miniature model of the familiar. And yet, you understand more. You understand that reality is not a static object. It is a set of relationships, defined by what can be done, by what can be measured, by what can be said. It is not waiting for you to notice it. It is produced, moment by moment, in interaction with your questions, your choices, your experiments. There is no need for vision. There is no need for a snapshot. Understanding arises in the patterns of possibility, in the harmony of outcomes, in the structure that remains when you strip away intuition. This is not emptiness. It is not unknowable chaos. It is a framework more subtle, more profound than any image could convey. You see now that your mind has been freed from the insistence that reality look like something you already know, freed from the crutch of classical expectation, freed to witness phenomena on their own terms. And in that freedom, awe emerges. Awe at a world that is stranger than your imagination, yet precise beyond your imagining. Awe at principles that govern without needing to be pictured. Awe at the quiet order behind every experiment, waiting only for the proper question to bring it forth. You realize at last understanding does not require sight. It requires surrender, surrender of expectation, surrender of the habitual crutches of the mind, surrender of the illusion that you must see to know, and in that surrender, you glimpse a new kind of clarity, a reality that does not obey your eyes, yet communicates everything you need to comprehend. This is quantum reality. This is the boundary of intuition, and this is where true insight begins.